A few sessions back, we saw Cauchy principle of sequence convergence. Now let's look at Cauchy principle of series convergence. So we have a series U sub n where U sub n is in the set of real numbers. Let S sub n be the nth partial sum and let S sub n in brackets be the sequence of partial sums. Now, what the Cauchy principle of series convergence says is a necessary and sufficient condition for the series U sub n to converge is that given epsilon greater than 0, there exists m in the set of natural numbers such that the distance between any two arbitrary points is less than epsilon for all p in the set of natural numbers and n is greater than or equal to m. So here, necessary and sufficient condition. So let's look at the necessary part and then let's look at the sufficient part of the condition. Now assume the series U sub n converges. Then the sequence of partial sums converges. Since S sub n plus p minus S sub n is equal to U sub n plus 1 plus U sub n plus 2 plus U sub n plus p. If we subtract these two partial sums, we get this. This condition is equivalent to the statement for all epsilon greater than 0, there exists m in n such that the magnitude of U sub n plus 1 plus U sub n plus 2 plus U sub n plus 3 plus plus U sub n plus p is less than epsilon for all n greater than or equal to m and all p in the set of natural numbers. So here, remember we are starting from n plus 1 and we are taking the sum up to or the series up to n plus p. So this series is less than epsilon for all n greater than m. That means such an m exists. For any two, when we say p in n, it means for any two arbitrarily distant partial sums. So by Cauchy criterion for sequences, we have for all epsilon greater than 0, there exists m in n such that the distance between S sub n plus p minus S sub n is at epsilon for all n greater than or equal to m. We have the absolute value of u1 plus u2 plus u3 u sub n plus p minus, we are subtracting the partial sum up to nth partial sum. So u1 plus u2 plus u3 plus plus u sub n is less than epsilon. Now when we subtract these two series, what happens? u1, u2, u3 to un gets removed from this. Since n is greater than or equal to m, the magnitude of u sub n plus 1 plus u sub n plus 2 plus u sub n plus 3 u sub n plus p is less than epsilon for all n greater than or equal to m for all p in n. So since we have this condition being satisfied, that means the condition, necessary condition is satisfied. Now let's look at the sufficient condition. Now, sufficient condition, basically we reverse the whole process. Conversely, assume that every epsilon greater than 0, there exists m in the set of natural numbers such that the absolute value of S sub n plus p minus S sub n is less than epsilon for all n greater than or equal to m and all p in natural numbers. Then that means what? The sequence of partial sums S sub n is a Cauchy sequence. And since every Cauchy sequence converges, that means the sequence of partial sums converges. and hence the series u sub n converges. A series u sub n converges if and only if the sum of its tails u sub n plus 1 to u sub n plus p can be made arbitrarily small for all sufficiently large n. That is, a sequence of partial sums is a Cauchy sequence. So that was Cauchy principle of series convergence. Now, if you found this session helpful, please do like, share, and subscribe. Comments, suggestions are always welcome. Thanks for watching. See you in the next session.